Yes, hello.
Then the
Yeah,
stage is yours and you can share your screen and yeah.
okay. Sorry.
Great.
Yeah, good evening, good morning, good afternoon, good evening, everyone. So, yes, I have this, I prepared this slide. So, yeah, I will talk about the RTX 2000 board. So, please excuse my slide. Uh, and yeah, first is, yeah, it has an Harris RTX 2000. This is just an overview. So, it's it's running at 10 megahertz and it's a 16-bit stack machine, and it's a dual stack architecture, which means data stack is 16-bit wide into 256 words, and return stack 21-bit wide and also 256 words. And it has two address bus and data bus. Address bus, there's a ASIC address bus, which is 3-bit wide, and for memory, it's 19-bit wide. And for data bus, yeah, both are 16-bit wide for ASIC and memory. And yeah, so for my board, it's actually from MPE. So it's a called RTX2000 power board, which has here we can see from the left side, here's the RTX processor. Then it has a 64 kilobyte RAM, which is this, which composed of two this static RAM, and it's expandable to 512, as well as the ROM. It has a 128. As of the moment, it has 128 kilobyte ROM, which consists of two EPROMs, which is this, and it's also expandable. And it has two serial ports using 853 chip, which is RS232 and the RS485, which is here. And there's also a SCSI interface using this chip. And there's also parallel IO using this chip, which is this port. And there's a 3-channel timer, which generates a time for the serial. And there are two expansion connectors, which is this passive backplane. And there's a pin here for local daughter board, but this is empty as of the moment. And there are also reprogrammable logic for memory and IO decoding, which are two Lattice GAL chips. I think it's these two, and Altera EP310. So yeah, this is the board components. And regarding the Forth that is running, it's called ROM RTX 2000 ROM Power Forth, which is this is the when we use the Tera term. And yeah, as the document state, it just occupies very small portion of the two EPROMs, and it's a complete 483 environment. And yeah, so how do we program this board? And it was mentioned three ways. So first is host PC as text file server. So we have host PC connected to the board using null modem. And we have suggestion is to use communication software like Procom, Crosstalk, Mirror, and we just use ASCII text file to send it to the board, and we can compile it and yeah, get the binary image into hex, and use the EPROM writer to write this to the EPROM, and we can replace this. Another method is called host PC running a Forth file server. So same setup, but using a different software, which is MP's cross-comparative Excel, where we can use ASCII text file for source or Forth screen file. And this shell also communicates with the ROM writer. So it will write the ROM, and we can replace the ROMs. And the third one is, yeah, it was mentioned, it can run standalone using a terminal. So yeah, the board, we need to connect a SCSI, a hard disk through SCSI, and a possible floppy disk using the power port. Then just using some terminal emulator like Hyper Terminal, Minicom, Teraterm. And yeah, these are some questions that, and so what's the reason why I had this board? So yeah, it's just my interest in how Forth engine were programmed using Forth during their prime. I think RTX was, yeah, those moment. Then my goal is to build a system that utilizes the full capability of the RTX. Like it was mentioned, it's capable for image processing, robotics, and Forth laptop is just one of my imaginations. And my current plan is to try some the intended devices like a SCSI drive, RS485 communication, and floppy drive VGA. And also maybe later I want to try some modern devices, connect modern devices like Wi-Fi, touchscreen, and SD card. And yeah, so for the demo, sorry that it's very simple, but yeah, let me share my screen to the other PC, which is connected to the board. Can you see my screen? Then let me start my video. So my video now is showing the board with the breadboard. Can you see the
We see the Teraterm window and an editor to the right, but we don't see a video.
It's actually the video of another account, which is Geo. Or let me open this camera from here.
Oh yes, I see it. Geo.
Yeah, that's because I use two accounts. Sorry. But yeah, so in the camera of this account, it shows the RTX board with the breadboard with LED. So, but yeah, my demo is just
I can't see any breadboard. I don't know what you guys are looking at. I just see the
on Geo. It's another account on the Zoom.
I went through them all. I couldn't see anything. I showed a breadboard. Oh yeah, I found it. Thank you. I'll shut up now.
Yeah. So that's the my board. The RTX is connected to a breadboard with LEDs, 4 LEDs, just the nibble. And yeah, for my demo, it's just I have this code in text. Actually, I was planning to make a better demo, but I underestimated. So just let me show this very simple demo. So as you can see, I use Teraterm, and it's now showing it's connected to the board and it's waiting now. So, and yeah, let me drop this demo text. So to do that, I need to command type the upload, and then it asks, it's waiting for the file. Here it says Procom, but good thing Teraterm has this. Yeah, we can drop the file also like this, and then Teraterm will ask. Then I just press OK. Then yeah, upload finish. Then yeah, I have this three functions of 3 words. So let me turn on some LED like first. So I will write. Then it will turn on. Then yeah, then other functions like shift left IO, and just then it's just shifting the LED, and then shift right IO, it's just shift the LED. So yeah, sorry that that's just my demo for today. But yeah, I plan to make more once. Yeah.
Fantastic. Excellent.
Thank you. But yeah, so I think that's all for my presentation today. If there's any questions, I'll try my best to answer.
Thank you very much. So yeah, it reminds me of the old times when we did RTX 2000 programming a long time ago. Yeah, I appreciate that.
So yeah.
Are there any questions?
That's the spirit of Forth. This is the spirit of what we expect from any of you that wants to participate in next meetings. There is nothing to prepare, nothing fancy. Just show us, hey, guys, I was working with this board. It runs. I am very happy because this is a super old system. It's a really retro computing. And for the first time, somebody shows us the RTX 2000. So it's amazing.
That's a nice board layout. Did you lay the board out yourself?
Sorry, you mean the power board?
The CPU board.
Sorry, no, I bought it. Actually, this is made by MPE.
Oh, right.
MPE.
Is the what's the signals on the DIN connector? What's available?
Let me share my other screen so I can understand. Let me share my.
The big white DIN connector at the bottom. I think that's SCSI, right?
Yes, is that address and data buses?
Do you mean this lower?
Yes, it's a DIN 4100 something, 92 or something.
96.
This one.
96
Yes.
pin connector.
96, excellent.
Yeah, that's the. Let me go. It's the for
expansion,
the
expansion
yeah,
bus.
expansion. Yes, and this pin has the pins for memory address and memory data and the ASIC address and ASIC data bus. Yeah, but yeah, one of my plan is also to try to use the ASIC data, and because most of these peripheral ICs are connected to the memory, and it's a memory map I also. But for the ASIC bus, yeah, it's mentioned that it's an IO that is very fast because it's connected directly to the RTX. So yeah, it's maybe, yeah, I'll try to see if I can utilize it with yeah, something.
Nice. Other questions?
Can you type words and show us what the current dictionary is on that device?
Yeah, sorry, let me share again my other screen. Share screen. Can you see my screen?
Yep.
Yeah.
Yeah. Words. It has some. Sorry, but yeah, these are the words, and yeah, there's a vocabulary. So yeah.
So is this like a 433 standard equivalent? Oh yeah, there it is, 433. Yeah.
So yeah, I'm still trying to yeah, learn more about these words, but yeah.
So do you have a handbook or source code of the system?
Yeah, I had these two manuals.
Great.
Comes, and yeah, and it has some explanation like what. But yeah, I can only do this during evenings after work or weekends, so progress is a bit slow. But yeah.
Cool.
Yeah, actually, I was attempting to make this delay so that, but unfortunately, it didn't work. Maybe, yeah, I misunderstood something. So that's why.
Here you can see I have a similar card, not an RTX, but this is the bus, the DIN 4000. It's very common, and this is an Euro card. I think George has a 1.5 of the size of an Euro card.
Oh,
because
yes.
because he has this SCSI extension on board. It's very nice.
Yeah, it has this SCSI, yeah, inside
It's
of
a very
inside.
it's a very powerful board for its time. It was an amazing technology, having all this development system in such a single board.
Oh,
As for the delay, I think what I saw was something like 100 for next. I mean,
yeah.
this runs really, really fast. So 100 for next is like 300 instructions or so, and that should not delay it much.
Actually,
you nested. I see you nested a couple of times. Yeah, but maybe. Yeah, we will see.
I see. Yeah, actually, I did this just today, and when I tried, it's not working properly. So yeah, actually, DLNS means delay nanosecond, and delay microsecond, and delay millisecond, and delay seconds. But
yeah, I see.
Seems it did not work as expected, so I just skipped this.
All right. So, are there any additional questions to George?
Does the RTX2000 execute a single Forth primitive in one clock cycle?
Sorry, I did not go into that deep yet, but yeah, I'm not very sure.
Low level work, like dupe or plus or something, because you said it was the clock speed was 10 megahertz, I think.
Yes, 10 megahertz, as it's based on the in the document it's mentioned.
Andrew, on the data sheet of these chips, these are all descendants of the Novix. We were talking about this before, but the RTX has more power than the Novix and was able to execute burst of up to 15 MIPS, explained on the data sheet with the 10 megahertz clock.
Right.
So this means that it was able to execute up to approximately 4 to 5 instructions in a clock cycle. And the mean was three instructions per cycle. It's remarkable for that time. It was an outstanding technology.